In today's video, we're going to take a look at what we mean by a magnetic material and the differences between permanent magnets and induced magnets. Now, one of the confusing things about magnetism is that not all magnetic materials are actually magnets. An actual magnet is any object that produces a magnetic field, while a magnetic material is any object that can be influenced by a magnetic field and has the potential to become a magnet. When we talk about which elements are magnetic, we're often referring to which ones are magnetic materials, not necessarily magnets. For example, even though nickel is a magnetic material, only some pieces of nickel will actually be magnets. The other common magnetic elements to know are cobalt and iron. And the alloys of these elements, like steel, also count as magnetic materials. And to help you remember this group, just remember that the first letters of each of the words spells NCIS. When we think about magnets, like a common bar magnet, what we're really thinking about are permanent magnets, which produce their own magnetic field all the time. There are another group of magnets, though, which we call induced, or temporary magnets, which only have a magnetic field temporarily. These are made when a piece of magnetic material, which wasn't actually a magnet, like your average piece of nickel, is put into the field of a permanent magnet. This induces the piece of magnetic material to develop its own magnetic field, with its own north and south pole, and thus we call it an induced magnet. And the key point to remember with induced magnets is that the force between a permanent and induced magnet will always be attractive, which is why the left side of our piece of nickel became a north pole rather than a south pole. If we then remove the induced magnet from the magnetic field, though, then it will lose its magnetism. Some magnetic materials, like nickel and iron, lose their magnetism really quickly, and we call these magnetically soft materials. Others, though, like steel, lose it more slowly, and we call these ones magnetically hard materials. Anyway,